Hello students, in this lecture also I am going to continue with the same topic, that is 8051 microcontroller programming. So the next program that I am going to discuss is write a program to add the first 10 natural numbers. So the natural numbers, first 10 natural numbers are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we need to add these 10 natural numbers and we have to write a program for this technique, for this problem. We have to write a program using the 8051 microcontroller instructions. So the logic is as given in the question, we need to add 10 natural numbers. So how many natural numbers? 10. So we will be setting the counter R2 is equal to 10. So this 10 means we have to add first 10 natural numbers. We have to add 10 natural numbers. This is showing the quantity of natural numbers that needs to be added. Then we will make accumulator is equal to 0. And one more thing, we will make R0, that is register R0 is equal to 0. Now we are making register R0 is equal to 0. Now what we will do, we will increment R0. We will increment R0. Now R0 after being incremented, it will be equal to 1. And then this 1, we will add it to the accumulator and the resultant will get stored in the accumulator. The resultant is 1. This 1 will get stored in the accumulator and R2 will get decremented. So R2 after being decremented, it will be 9. Which means if 1 is being added to the accumulator whose initial content was 0, if 1 is being added to the accumulator, so out of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 10 natural numbers, 1 is already gone. So remaining, we are decrementing R2, so remaining 9 natural numbers need to be added. Again we will go with the same process, that is we will increment R0. So initially R0 was 1, after incrementing R0 will be 2. Then we will add this value of R0 to the latest content of accumulator, that is 1 plus 2 is equal to 3, and this 3 will get stored in the accumulator and we will decrement R2. So R2 will get decremented and it will be 8, which means 8 more natural numbers need to be added. Similarly, again we will increment R0. R0 after being incremented, it will be 3, and this 3 we will add it to the latest content of accumulator, that is 3 plus 3 is equal to 6, and this 6 will get stored in the accumulator and we will decrement R2. So R2 after being decremented, it will be 7. So in this way the loop will keep on going. This 7 means 7 more natural numbers need to be added. 7 more natural numbers need to be added. So in this way this loop will keep on going until this R2 gets 0. When R2 after being decremented, it will get to 0, there only what will happen, whatever the result is stored in the accumulator, that is the addition of first 10 natural numbers finally, that will be stored in the accumulator. We will store that result into a certain memory location. So here we have used the memory location whose address is 46H. We have stored the result of accumulator in this into this memory location. Now let's see the program. I hope you have got the concept that we're going to use, the concept for this program that we're going to use. So let's see the program. So as I've told you, what are the steps we need to do? We need to make the accumulator is equal to 0. We need to make R2 is equal to 10. We need to make R0 is equal to 0. And then we have to increment R0. We will add the value of R0 with accumulator and we will decrement R2. The same loop will keep on going. So what we are doing, see the program. We have make accumulator is equal to 0. That is we are erasing any previous value of accumulator. If it is there, we are making it 0. So we are storing 0 value to the accumulator. Then move R2 comma hash 10 means we are storing the value R2 is equal to 10. As I have told you, we need to store the value R2 is equal to 10. Then move R0 comma hash 0 means we are making R0 is equal to 0. Then we are incrementing R0, that is we are incrementing one step by step. We will be incrementing R0. This is the loop that is going to get followed. So in this loop, first is we are incrementing R0. So whatever will be the value of R0, it will get added to the accumulator and the result will get stored in the accumulator. And then we will decrement R2, that is djnz R2 comma again means decrement the value of R2, and if the value of R2 is not 0, jump to this loop again. So what we are doing, we are incrementing R0, we are adding the content of R0 with the accumulator and the result is stored in the accumulator, and we are decrementing the value of R2, and if the R2 value is not 0, then again the same loop will keep on going, that is increment the value of R2, add the content of increment the value of R0, add the content of R0 with accumulator and decrement R2, and if R2 is not 0, jump to the loop again. So in this way, once R2 comes out to be 0, means all the 10 natural numbers have been added and the result is stored in the accumulator. Now move 46h comma a means we are storing the result of accumulator in this memory location. So this is the program to add first 10 natural numbers. Now let's see another program. Now this program will be using the instruction lcall. So lcall, it is basically a 3-byte instruction where the first byte is used for the opcode of this instruction and the remaining 2 bytes will be used for the address of the subroutine. So let's see the instruction. Let's see a program. So this is the program. What it is written: write a program to toggle all the bits of port 1 by sending to it the values 55H and AAH continuously. Put a time delay in between each issuing of data to port 1. This program will be used to test the ports of 8051 in the next chapter. So what they are saying, what we need to do in this program, we have port 1, and as we know, as I've told you when I was teaching you the pin configuration of 8051 microcontroller, that there are 4 ports in the 8051 microcontroller and each port consists of 8 pins. So similarly, port 1 will consist of 8 pins. So in this program, we need to toggle the values of 8 pins of port 1 by giving 55H and AAH. So what is 55? 55 is 0, 1, 0, 1, 0, 1, 0, 1. So once we will give this 55 to the port 1 pins, and then the next moment we will give AA means 1, 0, 1, 0, 1, 0, 1, 0. So what we are doing, we are toggling the pins of port 1. Initially we are giving 55, then after we are introducing certain time delay, then we are giving AA. Again we will be introducing certain time delay, again we will be giving 55. In this way we are toggling the pins of port 1. Toggling means, initially suppose let's see, this is one of the pin of port 1. So initially it was 1 when 55 was given to port 1, and then when AA is given to port 1, it is 0, 0, 1, 0, 1. This is toggling. So we are toggling the pins of port 1 by giving it 55H and AAH, and we need to insert some time delay in between issuing these 2 values to the port 1. So we have to write a program to implement this task. So as I have told you, ORG and END, these are the instructions to the directives. These are these directives. They basically tell assembler what to do, and ORG means start of the program, means whatever opcode is the instruction next to ORG, the opcode of that instruction will get stored in the memory location having address 000H. And END means it is the end of the program. So ORG 0 means it is it is telling that the next opcode of the instruction will get stored in the memory location 0000. So next instruction is MOV A comma hash 55H, means we are storing the value 55 in hexadecimal format 55H in the register A. Next is MOV P1 comma A, means we are giving port 1 the value 55. What we have done, initially we have stored the value 55 into A, then we are storing this 55 into port 1 using this instruction MOV P1 comma A, means we are storing the content of accumulator in port 1 and the content of accumulator is 55 only. So P1 will be 55H. Now lcall delay. So what is the function of lcall delay? Lcall, basically they are used for calling the subroutine. So whatever is written along with this lcall instruction, means this level, this is the subroutine call, means that subroutine will be implemented now. So whenever lcall is used in any program, the next instruction to the lcall, the next instruction of the program to the lcall, means here in this program, when lcall is used, the next instruction to lcall is MOV A comma hash 0AAH. The address of this instruction will be pushed into the stack and the subroutine will get implemented. After the subroutine is implemented, RET instruction is there. This RET instruction will pop the address from the stack and start executing the main program from that instruction. Again, I am repeating what is the function of lcall. The function of lcall instruction is, whenever lcall is implemented in a program, the next instruction to lcall in the main program, the address of that instruction will be pushed into the stack and the subroutine will get implemented. And once the subroutine is implemented fully, then RET instruction will bring back to the main program. How? It will pop out the address from the stack and it will start executing the main program from that instruction from where it was left. That is the address which was stored in the stack. So here lcall, so initially what has been done here, initially we have stored the value 55H into register A, then we have stored the value 55H into port 1 register. Then what we are doing, we are calling delay, because we have to call delay between toggling. When we are storing value 55 into port 1 and when we are storing value AA into port 1, in between these two processes we have to insert delay, because this is written in the question. So we are calling delay, lcall delay, and delay is this subroutine. So once this delay is called, the subroutine will be executed. What is the subroutine? MOV R5 comma 0FFH, which means R5 will get stored with this value FFH, then DJNZ R5 again, which means decrement the value of this R5, and if the value of R5 is not 0, then jump to this again. So again is starting from this DJNZ, means this loop is all about decrementing the value of R5. Since the value of R5 is FF, which means if you convert it into decimal, if you convert this value into decimal, it will be 255. FF means 255, and if you are using the delay, which is actually decrementing the value of R5 until and unless R5 gets 0, means the loop will keep on moving for 256 times. The loop will, this subroutine call will keep on going on for 256 times, and after 256 R5 will be 0, and R5 is 0, then no longer it will jump to again, then the next instruction will get executed, that is RET. Once RET is executed, the address that is stored in the stack will be popped out and the program execution will start from that instruction, means MOV A comma 00H. Now next instruction MOV A comma 00H means we are storing the value 0AA, we are storing the value 0AA into the accumulator. Then here 0 not 0, we are storing the value AA in hexadecimal format to the accumulator. and then MOV P1 comma A means we are storing the content of A into the port 1, that is we are storing the value AA into the port 1 pins, and then again we are calling delay. So the delay is the same subroutine here, that is we need to store, what does the delay subroutine says? Delay subroutine says MOV R5 comma hash 0 FFH means we are storing the value 55 into R5, then again DJNZ R5 comma again means we have to decrement this value of R5 till it gets 0. Once it gets 0, subroutine will get ended and the program control will get transferred to the main program, and after it gets transferred to the main program, the next program is SJMP back. SJMP back means keep on doing the same thing. So in this way we are storing 55H into the port 1, then we are introducing delay, that is we are using a loop which is repeating for 256 times, then we again the program control is getting transferred to the main program, we are storing the value AA to the port 1 pins, then we are introducing delay, the delay is the same subroutine program, and then again 55, then again A. In this way we are toggling the pins of port 1. So this was all about lcall instruction. Now next program that I am going to discuss is acall program. So in this program, acall, as I've told you, lcall is a 3 bytes program, whereas acall is a 2 byte program. When you're supposed to write a program where you need to save the memory space, you can use this instruction acall in place of lcall. So acall instruction is of 2 bytes. So this is also a program, same program, where we have to toggle the bits of port 1 with a delay which depends on the value of a number in R0, in R0. So depending on the value of R0, we have to insert a delay and we have to toggle the bits of port 1. So previously in this program they told us that toggle the bits of port 1 by introducing the values of 55 and AAH, but here they have not mentioned any value that we have to introduce 55 or A. They just have said that toggle the bits of port 1 and we need to introduce the delay where the duration of the delay will depend on the value of R0. So how we will be doing this? So org 0 will be the first instruction, then MOV A comma 0 hash 0. So what we are going to do here, we will be storing port 1 with 00H, we will be introducing delay, and then we will be storing the value FFH, then we are introducing the delay. So if you convert this hexadecimal 00 into binary, it will be 00000000, and if you convert FF into binary, it will be 11111111. So we are by own introducing this number 00 and FF, and we are toggling the pins of port 1 by using these numbers. So we are storing 00 to port 1, we are introducing delay where the duration of delay will depend on R0, then we are storing the value FF to port 1, then we are introducing the delay where the duration of delay depends on R0, again we are storing 00, again we are storing FF. In this way we are toggling the pins of port 1. Now we'll see the program. Sorry. So we will see the program what they have done here. So org 0, then MOV A comma hash 0. MOV A comma hash 0 means we are storing 00H to the accumulator. Then MOV P1 comma A means we are storing 00 to the port 1. That is, we are storing the content of accumulator to port 1 means we are storing the value 00 to port 1. Then we are storing the value R0 is equal to 30H. In the next instruction MOV R0 comma hash 30, we are storing the value 30H in the R0 register. Then we are calling delay. So this delay program again whenever you're calling a call delay, what will happen, the next instruction, the address of the next instruction will get stored in the stack, the subroutine will get executed, and once the subroutine is executed completely, when the RET instruction comes, the address that is stored in the stack will be popped out, and the program control will get transferred to the main program, and program execution will start from that stored address instruction. So this is a call delay. Next instruction was a call delay. A call delay means delay will be called and subroutine will get executed. So in delay subroutine, what is the first instruction? NOP means do nothing. Then DJ NZ R0 comma again means we have to in the main program we stored the value R0 is equal to 30H, and in the subroutine what we are doing, we are decrementing the value of R0, and if the R0 value is not 0, we'll keep on decrementing, and if it is not 0, it will again jump to this again loop and again will get executed, means this instruction will keep on executing until and unless R0 gets 0, and once R0 gets 0 means no more jumping to this again loop, and then RET will get executed. Once RET gets executed, the address of the next instruction means CPLA, this instruction address which was stored in the program count in the stack will be popped out, and it will be popped out, and the program control will start will be transferred to the main program, and program execution will start from this instruction. Now CPLA means complement A. Initially the value of accumulator was 0 0. Now if you complement A, it will be FF H. Then MOV P1 comma A means we are storing the value of accumulator into P1. So what is the value of P1 now? It is FF. P1 is also FF. We have toggled it. Now we need to introduce time delay. Now again we are storing R0 is equal to 0 comma hash 0 FFH, and we are again, so here you can store any value in R0 because it depends upon you. Here we have chosen 30H and FFH accordingly. So after storing FFH into R0, we are again calling delay, a call delay. So again delay subroutine will get executed where the first program NOP, first instruction NOP is do nothing. Then DJ NZ R0 again means decrement the value of R0, and if not 0 then jump to this loop again, and this instruction will be executed continuously till R0 gets 0. So this time R0 value is 0 FF, and it will keep on decrementing until it gets 0, and once it gets 0 and RET instruction comes, means the address of the next instruction will be popped out from the stack, and the program execution will start from this instruction SJMP start. So SJMP start is a short jump. Start means again the same thing will start from the very beginning, same process will keep on moving, means once P1 will get stored with 0 0. What is the logic here we have used? We have stored P1 is equal to 0 0 for toggling the pins of P1. We have first stored P1 is equal to 0 0. Then we have called delay by storing the content of R0 is equal to 30H. We have called delay so that the duration of delay, that is by decrementing R0, will depend accordingly to the value of R0, and once it is decremented completely, once R0 is 0, again P1 value will get stored with FF, means the pins have been toggled, and again we are introducing delay, and this time we are storing the value of R0 is equal to FF, and we are calling delay where the duration of delay will depend upon the magnitude or the amount of R0, and the delay will be executed. Once the delay is executed completely, that is once R0 is equal to 0, once R0 is equal to 0, again the it will transfer to the main program control will be transferred to the main program, and the same process will keep on moving. So this was all about the this ACALL instruction program. We'll continue with the 8051 microcontroller program in my next lecture also. I'm ending this class here. Thank you.